Hi there. Today we're talking about our final topic of topic 3, markups and markdowns. This one topic is probably the one that I use most in my real life. Whenever I'm shopping, I'm always looking for the sales, how much I'm going to be saving, what I'm actually going to be paying. So if you notice at the beginning, we have 3 vocabulary words. Again, we talked about these in class briefly. They are the cost, which is the price at which a company buys an item. The selling price. This is also known as the retail price, and it is the price a company charges a customer for an item before tax is added on. If you ever look at a price tag on clothes, sometimes they say MSRP. That stands for manufacturer suggested retail price. So that's, again, selling price. And profit is the difference between the cost and selling price of an item. So that, again, this is very similar to what we talked about yesterday with increase-decrease, because a markup is an increase, a markdown is a decrease. So they're saying markup is the amount of increase from the cost to the selling price. So just like to find the amount of change, which was the amount of increase, this time we're going to be using the vocabulary word selling price and minus the cost to give us the amount of markup. Then to find the percent markup, that equals the markup divided by the cost. Now what they're really doing, where this is coming from, is our part equals percent times whole formula. If I was to write our formula that we've been using, part equals the percent times the whole, if I wanted to get the percent by itself, I would divide both sides by the whole, which would leave me with the percent markup equal to the part divided by the whole. So the markup is the part, the cost is the whole. Question number 1 wants us to find the percent markup for each item, and they want us to make sure that we round to the nearest percent. So we have a notebook, a bicycle, and a car. The notebook, I'm going to label my work. The notebook, the original price was 25 cents, the cost. And the selling price is $1.50. So I'm going to do $1.50 minus the 25 cents to get $1.25. But I'm going to take a little shortcut here, and I'm going to place that over the cost here, which was 25 cents. I'm going to simplify what's in the numerator. I divide this out, and I get 5. I want you to be careful. My answer is not 5%. To change this whole number to a percent, I have to multiply by 100. So it means my percent is actually going to be 500%. For the bike, I'm going to take the selling price and the cost, and again, I need to subtract those two, and I'm going to place both of those divided by the cost. This all equals my percent markup, so I have to simplify this to get me 120 divided by 180, and it'll give me 66666, a repeating decimal, and so on. When I round to the nearest percent, though, it will give me 67%. Be careful. We don't want to lose points because we can't round correctly. Then we have the car, which is $12,000 for the selling price, minus the $8,000 of cost to give us and then, sorry, I forgot that I need to divide it by the cost, which is 8,000. So now I have 4,000 divided by 8,000, which gives me 5/10, which is the same thing as 50%. You just have to be clear that the formula that I'm using, and I'm saying formula, markup divided by cost, is telling me what the percent markup is. So you have to be careful that you do convert your answers to percents. I'll go ahead and let you guys try number 2. Just know that when they say base cost, that's the same thing again as cost. This one wasn't specific about where to round, so I just rounded to the nearest whole percent. Again, we have to find the amount of markup that there was, so we had to subtract the selling price and the base cost to give us the 240. I imagine that most of you are probably going to skip, sorry, I meant to hit that. You're probably going to skip this step, but I'm cautioning you against, again, taking shortcuts. So I divide that out. I now have a fraction, which I'm going to convert that fraction to a decimal, and then I finally convert it to a percent. I was going to say try number 3 on your own too, but there's just one extra step here that we need to be careful about. It says that the concert halls change the price for concert tickets depending upon the performer. If they think that it's somebody that a lot of people are going to come see, they'll probably charge more. What is the selling price for the concert ticket below? So notice here they didn't ask what is the percent markup. Here they're giving us the base cost and they're giving us the percent markup. So again, if we go back up and think about the formula they gave us, which was the percent markup is equal to the markup divided by the cost. Now, I'm not crazy about this because I don't want you guys to have to sit here and feel like you're memorizing a formula. If you want to, there's absolutely nothing wrong with you thinking y equals mx to yourself. There are so many different ways to solve this problem. I don't want to go through all of them and confuse you, but if what I show you is confusing you, please ask me. So the two equations that I have written down are basically saying the same thing, but one of them has the percent by itself, the other one would have the part by itself, because remember we said that the y was the part. So if I was to go through and continue this one here, 90% is 90 divided by 100. I'm trying to find the amount of markup, and then the cost is 20. So if you look at this, it almost looks like I have a proportion right now, and you could solve this as if this was a proportion. So you could say to yourself, how do you go from 100 to 20? Well, don't I divide by 5? So wouldn't I have to do 90 divided by 5 as well? And that would give me 18. So I could do it that way. You could go through and multiply both sides by 100. If we wanted to use the y equals mx formula, because we're looking for the part, I would put in 90 divided by 100, and then put the base cost of 20 over here. So, then I could go through and I could work this out, and I still would get an answer of 18. Now, the base cost was 20, but then the amount of markup was 18, so I have to add those two together to get $38. Again, this is the base cost. The 18 is the markup, and then that will get me the selling price. I hope I haven't confused you too much. Okay, going on to the back, they're talking about markdowns now, which again, a markdown is just an amount of decrease from the selling price to the sale price. And sale price gets confusing because it can take on two meanings. Some people think that selling price is sale price, but then also when you take a percentage off, that is also your sale price. Big difference between amount saved and amount that you pay. So again, they're giving us percent equals the markdown divided by selling price, which is also the same thing if we think about the part equals percent times whole, which is our markdown equal to the percent of markdown, just move this, times the selling price. Oh, that should be selling there. Again, if you just kind of keep coming back to the y equals mx, it'll help you get out of the jam of how to solve the percent problems. So number 4 says that 5 years ago, a furniture store bought sofas for $835 each. What is the greatest whole percent that the manager can decrease the price of the sofa without losing money? Okay. Well, first of all, when I read this question, it says that $835. I need to decide, what is that? Is that the original? Is that my whole? Is that my part? Is it my markdown? Is it my selling price? What word could I establish with that? I would say that if the furniture store bought it, this is the cost. Now, it was $1,599, which that was the selling price. They want to find how much can I mark it down where he will actually still make money. Okay? So, again, if I'm thinking to myself that I'm finding the percent markdown, I have to first find how much can it be marked down from the selling price to how much he actually paid for it. So I have to take the $1,599 and subtract the $835 because that's the cost, and the $764 will give me the amount of markdown. So I'm going to take the $764, put it over the selling price, the original price in this scenario, which was $1,599. That will give me 47,777, so forth. And so your habit here, because they said what is the greatest whole percent that the manager can decrease the price of sofa, some of you are thinking, oh, 47, that rounds up to 48. Well, we have to be careful here, though. If he takes 48% off, though, he's actually going to be selling it for less than what he paid for it. So we can't round it up to 47 or 48. It will just stay at 47%, because if you go up to 48% off, it'll be too high. So the answer is technically 47% here. Kind of a trick question. So number 5 says that each month at an electronics store, new televisions come in. The store manager puts older televisions on sale. What is the percent markdown on the television below? So they're giving us the selling price and the sale price. So I'm just reminding myself that I'm finding a percent markdown. So I take the selling price, which was $250, subtract the sale price, which is $200, and then divide it by $250. So I'm really trying to find my M here. I get 50 divided by 250, which equals 2/10. But then I need to be careful, since this is a percent, I have to change it to a percent and get 20%. If you need to ever stop and look back at things I'm going over, I would suggest it. Number 6. We talked briefly about this in class 2 as well. They're saying that the Relax Yoga store buys yoga mats at cost for $15 each. So the yoga store has to sell the mats for at least $15.01 to make any type of profit. The store charges $38.99 for a yoga mat and has a sale for 20% off of a mat the following week. So does the store still make a profit on each mat during the sale? If so, how much of a profit? So again, we talked about that if something is on sale for 20%, then that means you're actually going to pay 80% of the original. If we go back to our first set of notes on 3-1 talking about the percent equation, of the original meant we were multiplying by the original price. So if I come back and use this y equals mx, which is the part equals percent times whole formula, I need to find out if I can actually, what the markdown's going to be. So there's 2 things we can do here. I can find 20% of $38.99, get an answer, and I'll tell you, of $7.80, which then will be my amount of markdown. Because if the sale is 20% off, then I need to take off 20% of $38.99 to get me $31.19. Or I can just go ahead and use 80% right in my formula, do the subtraction now. You can convert 80 hundredths to 8/10 if you'd like. And 8/10 times $38.99 would give us $31.19. So that's how much the yoga store would now sell the yoga mats for. So this is what the new selling price. And the question's asking, will they actually still make a profit? Well, if they can turn around and sell the mat for $31.19, subtract their original cost that they had to put in, it gets $16.19, which means they would still make a profit of $16.19. They've already paid the $15, so we have to subtract that off. Number 7 continues and says that the Relax Yoga store now negotiates to buy even more yoga mats from their seller if he can give them 35% off of the original $15. If the seller gets the mats for $8.50, would he still make a profit on each mat with this deal? If so, how much of a profit? So if you can give him 35% off, 35% off means you'll pay 65% of the original. So I'm going to find 65% of 15. Again, I'm going to change 65 hundredths just to a decimal. Reminds me of the I equals PRT formula. Multiply those out, and I should get $9.75. So the seller that supplies the mats to the yoga mat store would sell them for $9.75. They've had to pay the $8.50 already. How much profit will they get? $1.25. So it's $1.25 profit for the seller. We'll work on practice 3-6 in class tomorrow, so if you have any questions, you be sure to ask. Have a great night.